Hello everyone, welcome to my channel Physics Tricks. So let's start with Fluid Mechanics DPP 4, and in this we have 16th question from HCV Verma. As you can see, a cubical block of wood weighing 200 gram has a lead piece fastened underneath. Find the mass of lead piece which will just allow the block to float in water, and they gave specific gravity of wood and that of lead is. So this is the condition given. This is the wood we have. This is the lead which is fastened underneath the wood, and this is floating inside the water. ठीक है ना? This combination is floating inside the water. ये ऐसे कुछ होगा. ठीक है ना? Now see, over here. Find the mass of the lead piece which will just allow the block to float. Okay. So over here, mass of wood plus mass of lead into acceleration due to gravity is balanced by what? Buoyant force. So you can write buoyant force as mass of wood plus mass of lead into acceleration due to gravity. Okay, na? Okay. So buoyant force, always remember one thing. What is buoyant force? Density of the liquid it is 1, because density of the water is given. Volume displaced is volume of wood plus volume of lead into acceleration due to gravity is equal to mass of wood is given 200 gram plus mass of lead that we need to calculate into the acceleration due to gravity. This G get cancelled. And volume of wood we can write mass of wood divided by the density of wood, that is 0.8, plus volume of lead we can write mass of lead divided by density of lead, that is 11.3, is equal to 200 plus mass of lead. So from this we can write we have 2000 divided by 8 minus 200 must be equal to mass of lead in the bracket 1 minus 1 by 11.3. तो अगर इसको आप solve करोगे तो you will get the mass of lead, and this is 4 2s are 4 5s are, so 250 minus 200, it will become 50 is equal to mass of lead in bracket, this is 1.3 divided by 11.3. Sorry, it is not 1.3, it is 10.3 है ना. 11.3 minus 1 is 10.3, right? Okay, so mass of lead we have is 50 into 11.3 divided by 10.3. अगर आप इसको solve करोगे, just solve, just a minute. It is given 50 into 11.3 divided by 10.3, and you will get 54.85 gram. ठीक है ना, 54.85 gram. So this is how you need to solve. Now 17 and 18 is similar type. So as you can see over here, 17th problem, solve the previous problem if the lead piece is fastened on the top surface of the block and the block is to float with its upper surface just dipping into the water. मतलब अभी हमने क्या किया है, ये जो वुड है उसके अपर पार्ट में इसको फास्टन किया है, इसको बांधा है. ठीक है ना. तो एंड इनसाइड वाटर ये है, इनसाइड वाटर. ठीक है, तो ये हो गया इनसाइड वाटर. चलो ठीक है, तो इसमें क्या लिख सकते हैं अपन, देखो सेम थिंग हियर आल्सो, मास ऑफ द वुड प्लस मास ऑफ द लेड into acceleration due to gravity is balanced by what? Buoyant force. So buoyant force B is equal to mass of the wood plus mass of the lead into acceleration due to gravity लिख सकते हैं. What is the buoyant force over here? Buoyant force is density of the liquid 1 into volume displaced is the only volume of water now, right? Sorry, volume of wood now, right? Into the acceleration due to gravity is equal to mass of wood is given 200 gram plus mass of lead we want into G. So this G get cancelled. Volume of wood we can write, and that is equal to mass of wood 200 divided by 0.8, which is equal to 200 plus mass of lead. Now if you just find out, you will get this is equal to 250 minus 200 and that is equal to 50 ग्राम. So I hope this is clear. तो अगर नीचे इसको लगाएंगे तो 54.85, राइट. नीचे अगर लेड को लगाएंगे, फास्टन करेंगे, तो इट विल बी 54.85, इट विल बैलेंस. एंड अगर ऊपर लगाएंगे तो इट विल बी 50 ग्राम, इट विल balance. So I hope this is clear. Now see, in this 18th question, a cubical metal block of H 12 centimeter floats in mercury with 1/5 of the height inside the mercury. So we have mercury in a beaker, ठीक है ना, and inside this mercury we have a metal block with 1/5 of its volume inside it, ठीक है. Or else height it is given h by 5, you can write. Okay, so this side is 12 centimeter given. So from this we can find what is called as the density of this. And what is the density? So how to find the density? It is mg, which is balancing what is called as the buoyant force, or buoyant force is balancing mg. So buoyant force B is equal to mg, we can write. So buoyant force, we can write density of the mercury, that is 13.6 into volume displaced is volume 12 cube divided by 5 into the acceleration due to gravity is equal to the mass into acceleration due to gravity. Mass of the metal block is density of the metal block, rho into 12 cube into g. So this g, this 12 cube, this g, this 12 cube can cancel, and rho of the metal block we have is 13.6 divided by 5. Okay, now what they did is water is poured till the surface of the block, it just immersed in it, ठीक है. तो अब जो है वाटर जो है वो इनसाइड द वेसल पोर किया है, ठीक है. तो ये हो जाएगा हमारा मेटल ब्लॉक, ये हो जाएगा हमारा मेटल ब्लॉक. इसके अंदर हमने क्या डाला है, वाटर डाला है टिल द सरफेस ऑफ द मेटल ब्लॉक वेट सपोज टू बी. तो यहाँ पर जो बॉइंट फोर्स होंगे वो होंगे ड्यू टू द मर्क्यूरी प्लस ड्यू टू द वाटर. वो बैलेंस किसको करेंगे, mg को करेंगे, ठीक है. So we can write buoyant force due to mercury plus buoyant force due to water must be equal to mg. तो यहाँ से आप देख सकते हो density of the mercury is 13.6 into volume displaced in mercury. Let us consider that is 12 minus x, है ना, 12 minus x. ये x अगर कंसिडर किया तो ये 12 minus x हो जाएगा. 12 minus x into 12 squared into g plus the buoyant force in water is 1 into x into 12 squared is equal to into g is equal to mass density of the metal we have into volume we have is 12 cube into g. So ye g get cancel, 12 squared 12 cube 12 squared get cancel, and we can have that is 13.6 in bracket 12 minus x plus it is x is equal to, we have density of the metal just now we have found out, and that is 13.6 divided by 5 into 12. So अगर इसको सॉल्व करोगे आप, so you will get 12 into 13.6 minus 13.6 x plus x is equal to 13.6 into 12 divided by 5, and as you can see 12 into 13.6 common, 1 minus 1 by 5 is equal to 13.6 x minus x. बस अब इसको सॉल्व करो. सो 4 by 5 into 12 into 13.6 is equal to, we have this is 12.6 x. So अगर इसको सॉल्व करूँ मैं तो x इज इक्वल टू मिल जाएगा मुझे 4 इंटू 12 इंटू 13.6 डिवाइडेड बाई 12.6. तो इसको सॉल्व करते हैं अपन, डिवाइड बाई 5 इंटू 12.6 ना. So 5 is there already over here, so into 5. तो अगर इसको सॉल्व करूँ मैं तो you will get 4 into 12 into 13.6 divided by 12.6 divided by 5, and you will get x is equal to 10.36 centimeter must be inside the water. ठीक है, 10.36. हमको क्या चाहिए? Water is poured till the surface of the block. It just even find the height of the water column. तो height of the water column कितना है? 10.36, मतलब 10.4 centimeter of water we have to pour into the vessel. ठीक है, चलो next 19th question. A hollow spherical body of inner and outer radii given 6 centimeter and 8 centimeter. So एक hollow spherical body, this is the hollow spherical body is given, जिसका inner radius कितना है? 6 centimeter, outer radius कितना है? 8 centimeter, half submerged into the water. So it is half submerged into the water as you can see over here. ठीक है. Find the density of the material, है ना? Find the density of the material. Now as you can see, who is balancing the mg? Who is balancing the mg? Mg is balanced by what? The buoyant force. So buoyant force B is equal to, we can write mg. What is buoyant force now? Buoyant force is nothing but the density of the liquid, that is 1, into volume displaced. Volume displaced can we write 4 by 3 into pi into r cube, as in 8 cube, into 1 by 2, because half of this is into g is equal to mass of this is density of this material into volume. Volume we can write 4 by 3 pi r cube minus r1 cube minus r2 cube, that is outer minus lower, right? Outer minus inner, right? So it is 8 cube minus 6 cube into g. So this 4 by 3 pi, this g, this 4 by 3 pi, this g get cancelled, and we have rho as 8 cube divided by 2 times 8 cube minus 6 cube. अगर इसको आप solve करोगे, so you will get this is 8 cube as in 8 into 8 into 8 divided by 2 into 8 cube minus 6 cube as in 8 cube minus 6 cube. Chalo, we'll solve now. 8 into 8 into 8, 512 divided by 2 in bracket 512 minus 6 cube is 6 into 6 into 6, 216. So this is equal to 512 divided by 2 into 296, which is equal to, if you just solve this, you will get, this is 2 1 2 2s are, then 2 5s are 256 divided by 296. So it is 256 divided by 296, you will get 0.865. So the density we have is 0.865 gram per centimeter cube or 865 kg per meter cube. So I hope this is clear. Now the last question we have, and that is, a solid sphere of radius 5 centimeter floats in water. If maximum load 0.1 kg can be put on it without wetting the load, find the specific gravity of the material. So this is the solid sphere we have, on which 0.1 kg we can put maximum. So over here, who is balancing this 0.1 plus mass of the solid into the acceleration due to gravity? It is the buoyant force. So buoyant force is equal to 0.1 plus m into g. Now what is buoyant force? Density of the liquid. It is placed in water. That means 1 into volume displaced is the volume of a solid sphere. It is 4 by 3 pi into r cube. R cube is 5 cube is equal to 0.1 kg, as in 0.1 into 10 to the power 3 plus mass of this sphere. We can write it as density into volume. Volume is 4 by 3 pi into 5 cube. Now if you just solve this, you will get this is equal to what is called as 4 into 3.14 into 25 into 5, 125 divided by 3 minus 100 is equal to density rho into 4 into 3.14 into 125 divided by 3. Chalo, let's solve this. It is 4 into 3.14 into 125 divided by 3. It is 523.33. 523.33 minus 100 is equal to 523.33 rho. So if you just solve this, you will get this is 423.33 divided by 523.33, which is, so if you just solve this, 423.33 divided by 523.33, you will get 0.8 gram per cc, 0.8 gram per cubic centimeter. This is the answer for this question. So I hope this is clear. Right, so all the questions are based on the buoyant force. Buoyant force is equal to the weight that is balanced, right? So I hope this is clear. Now if anyone has any doubt, they can always comment in the comment box. I'll try to reply to your comment as soon as possible. Thank you so much.